For summation notation, we are finding the sum again, but we just write in a different notation. We use this term right here. It's called sigma. And it looks like a backward E. And what you do is you put the index of summation where you start. You can say n equals to, but here they use k equals to 1. So you start adding the first term up to, when you look at this example, you add up to the fourth term. And you write the rules after the sigma. So the first one is k squared minus 3. So what we're doing is, you start from the bottom number, which is 1, and you increase k until it becomes the number on top. So first, 1, when you plug it in 1 to the expression, it's 1 squared minus 3, which is negative 2. Then summation means what? Plus. Now it's 2. You plug it in 2. 2 squared is 4, minus 3 is 1. Now I've done the second one. Now it's the third one. When k is 3, 3 squared is 9, minus 3 is 6. And my next one is 4, and that is our last term. When you plug in 4, it's 4 squared 16 minus 3, which is 13. Then you add it. So what is negative 2 plus 1? Negative 1 plus 6, 5 plus 13 is 18. So that's your sum from k 1 to 4. Yeah, that's k. Yeah. Yeah. Number 2. This time you only have 3 terms. That's nice, right? So when k is 1, 1 minus 1 is 0. So 0.1 raise it to 0 is 1. So your first term becomes negative 2. This one is geometric. Remember the geometric sequence explicit rule? It's the first term times the ratio. Raise it to n minus 1. So when k is 1, this is your first term. When k is now 2, it's 2 minus 1, which is 1. 0.1 to the first power is 0.1 times negative 2 is negative 0.2. Now, third term, which is our last term, it's squared because 3 minus 1 is 2. So 0.1 squared equals to what? 0.01 times negative 2 is, you're adding it with negative 0.02. So then you get negative 2.22 as the sum. Negative 2 minus 0.2 minus 0.02 is negative 2.22. Okay? All right, so number 3. So how many terms are we adding? 5. So the first term is, when you plug it in 1, it's negative 3 plus 25, which is 22 plus, then when it's 2, negative 6 plus 25 is 19. Then what are you doing? What is this? Aren't you subtracting by 3 each time? It's arithmetic series. So it is 16, 13, and 1, 2, 3, 4, 5. So you get, what do you get when you add all of them? 80. That's your answer. Number 4. Now you start from 0. So start from 0. When you plug it in 0, since it's not k minus 1, this is gone. And you just get 1/3 plus, when it's 1, it is 2 to the first power times 1/3, which is 2/3, plus what? What are we doing each time? Multiply by 2. And how many terms we have? 4? No, it started at 0. So there will be 5 total. So it is 8 over 3 plus 16 over 3. 1, 2, 3, 4, 5. So when you add it, what do you get? 3, all common denominators. So 3 plus 4 is 7, plus 8, 15, plus 16, which is 31 over 3. Yes, just leave it as an exact number, fraction. What about 5? How many terms do you have this time? It started from 1, so it's 5. 1, 2, 3, 4, 5, 5. So, and it's 1 minus 1, 0. So you start from 4. And what do you notice? This is geometric. What do you multiply each time? Half. Divide by 2. So it's 2, 1, half, 1/4, 1, 2, 3, 4, 5. And also double check. When you plug it in 5, you get 4. So it's 4 times 1 square to the 4th, which is 4 times 2 to the 4th is 16, which is 1/4. Is that what we have? Yes, double check. So then what do you get? This one would be easier to just plug into the calculator, or this is 0.5. This is 0.25. So when you add it, it's 7.75. Is that what you get? 7.75. Okay? Now we're going backwards. We're going to write the summation notation using sigma when they list out the series. So let's go ahead and find which sequence it is. It could be arithmetic, geometric, or something else. What are we doing here? Multiply by 3, so it looks like it is geometric. So you start from, let's just start from 1. I think it's easy to start from 1, then 0. If you want to make the equation, start from 0, that's fine. But usually it's easier to do it with 1. And write the rule. What's the rule you do for geometry? You put the initial value times the ratio, which is 3, raise it to what? N minus 1. I use N here, then you have to use N. If you use K, you can put K. And how many terms are there? 1, 2, 3, 4, 5, 6. So it's 1, 2, 6. And double check your work by plugging those numbers. What about 7? This one is a little harder. Why? Do we know how many they added? It's there dot, dot, dot. That means we don't exactly know how many. That's what we have to figure out. So let's go ahead and find the rule first. What are we doing each time? Subtract 5. So this is arithmetic. So what is the rule for the arithmetic? You start from the very first term plus n minus 1 when he comes back. N minus 1 times the difference, which is negative 5. Can I leave it like that? No, please simplify it. So here, if I were to simplify it here, it's 87 minus 5n plus 5, which is negative 5n plus 92. Is that right? So I have negative 5n plus 92. I'm almost done, except I need to know how many terms I was adding. What should I do to find the number of n? Right. Set this equal to what? 32, our last term. This is an, right? The term that we're looking at. So 32 equals to negative 5n plus 92. So then you solve for n minus 92 from both sides. So then you get negative 60 equals to negative 5n divided by negative 5 and negative 5. So n becomes 12. Then where do I put 12? On top of the sigma. How can I double check? Plug it in 12 and see if you get 32. So number 8. What are we doing? What's the rule? It is 2n minus 1 squared, it looks like, right? So what do? You write sigma, and let's start from, would it be 1? Let's see. What is 2 times 1? 2 minus 1 squared, 1. You have to be careful because sometimes it can start from 0. You have to double check whether it's 1 or 0. So this case is 1. And the rule, they gave it to us, so it's easy. 2n minus 1 squared. And what is the n here? N is just n. We don't know what that n is. They just put n. So we're adding up to n. What about the second one? What are we doing here each time? Times by -4. So this is geometric. So sigma, let's start from 1. And how do you write a geometric sequence? Rule. You start from the very first term. And the ratio, which is -4, raise it to n minus 1. And what does this ... mean? It's keep going to infinity. So what do I put for infinity? You put infinity, positive infinity for the maximum number of n.